So this is the second video for lesson 7.2 day 2. In the first video, I whizzed my way. We went through these problems. So this is part 2 of today's lesson. For this one, we're going to have to write an equation for an ellipse with the following. We know the length of the major axis and the length of the minor axis. I would strongly suggest you grab those points. 1, 2, 3, 4, 5, down 2. Okay, that's the major axis. That's taking me to one of the vertices. And the other one is at -1, -2. Okay, so at this point, I will automatically know, I can already tell where the center is. The center is going to be there. And when I write the equation of ellipse, I know I'm going to be doing x minus h squared plus y minus k squared over a number equals 1. Okay? And my h and my k are going to be from this point here. I've just worked out the center is halfway between those. You can do it sort of look along there. It's halfway between 5 and -1. It's at 2, -2. So I'm already can put some of the information in. X minus 2 squared plus y plus 2 squared, subtracting -2, equals 1. And I now know I'm going horizontally across 3, across 3. So I don't really care if that's called A or B at this point. I really don't care. Well, it will be A because they're going for vertices. But because it's horizontal, that's changing X. It's going to go under here. But I don't just put that value, I have to square it. Now, if it's a big awkward number, we don't mind you writing 3 squared. But hopefully you can do 3 squared in your head. Yeah, 3 squared is 9. Now let's see where we're going to be going with the minor axis. I've got a point at 2, 0 and a point at 2, -4. So this distance here is 2 up and down, so I must have 2 squared under y. Done. That's all there is to that. That's all you need to do. This one is, if we grabbed it in, would be horizontal, and we could now work out where the foci are, but it doesn't ask for that. Let's move on. Write an equation for ellipse with the following. This one might be a little harder. Let's see. We know the vertices are, so the distance from one vertex to another vertex, that distance is going to go through the center, and it's going to be A and A. But what's changing here? It's not the x's. Oh, no. The x's are the same. So what I've actually kind of thought of in my head there is wrong. This one's going to be going like this. Right in amount A. That's going to be your center. Okay? So how much are we changing by? It might be just easier just to graph it. I can see that's actually changing by 10. Go all the way from there to there is 10, so I can actually see just looking at that my A is 5. But if you want to draw a nice neat graph, if you don't understand what I've just explained there, then just plot those points neatly and count everything out. So we've got to go across 3, then down 4, label it with a V for vertex, and then across 3 and up 6. 1, 2, 3, 4, 5, 6. Okay, so hopefully you can see there that the center is here. The center is at the point 3, 1, and we're going up 1, 2, 3, 4, 5. Going to a vertex. A is 5. And so that can start. We can already put quite a lot of stuff in the equation. The equation is going to be x minus h squared plus y minus k squared equals 1 over some number squared and some other number. Those would be 2 different numbers. I know I'm going up and down by 5, so So that number there is going to be 5 squared. It was vertical change, so 5 squared is going to go in there. So what do we know? We know the HK point. So we know we've got x minus 3 squared plus y minus 1 squared equals 1. And we know that to get from the center to the vertices, we're going up and down by 5. 5 squared, and a squared is proposed in the equation, will be 25. And that was a vertical change, so I put it underneath the y. But now there's going to be another number under here, and it's going to be my b squared, and I haven't got any information on that. But what have I not used from the information they gave me? My first side were at 3, 4, and at 3, negative 2. That's a good colour to do that. So 3 cross 1, 2, 3, 4. One of them's there. It's a focus, and the other one is at 3, negative 2. So I'm going up 3 and down 3. That's my value of C. See, from the center, I'm going up 3 and down 3 to get to the foci. So that's telling me that C equals 3. But C doesn't appear in the equation. I need B squared. I know A squared equals 25. I don't know what B squared equals, but I do know the difference between those numbers would be C squared. And if C equals 3, then C squared must be 9. So what number's missing in that gap? What do you subtract from 25 to get to 9? 16? 25, yes, that works. So my B squared is 16. That's what goes here. Don't go squaring it or square rooting it. We actually want B squared itself. Done. Okay, for the rest of the lesson, I'd like you to spend some time practicing completing the square. Now, this is a mixture. Can you identify more practice completing the squares to convert to graphing forms? You don't need to graph them, but practice completing the square. And as you're doing it, can you identify which is an ellipse, which is a circle, or a parabola? There's a mixture, 5 different questions here. Challenge, try to solve all 5 in 5 minutes. That is a heck of a challenge. What I do suggest you do, if you know you're going to work a bit slower, just do the odd ones. Okay, then come back and do the evens. Okay, so pause your video now when you've done as many as you are going to do, then come back and I'll give you the answers. One thing to notice on question 3, the coefficients in x squared and y squared are the same, and when you divide that out, that means that these are going to have, when we've completed the square and everything gets divided out, these are going to end up having the same denominator. So it's going to be an ellipse with an x minus h squared plus a y minus k squared equals to 1, where these numbers are both going to be the same. So the, let's call them, I don't know, k squared. No, I can't use k. Here's a variable I've already got in there. Let's call it r squared. Ha ha. Why did I call it r squared? If you multiply both sides by r squared, you've got x minus h squared plus y minus k squared equals r squared, which is a circle. And if you think about graphing this, if your center is your hk point, you're going square root of r squared, you're going r, left and right, r, up and down. This is going to be a circle. The only one that sticks out as being different here, did you notice that in 5 there is no x squared term? It's only y that's being squared. I hope when you've completed the square on this one, not only did you subtract 12 to both sides, but you also move that x to the other side. then you'll be adding in a box when you complete the square. This is going to be a parabola. And it's going to be a parabola where you've got y squared. I don't know if it's going to be positive or negative yet. You can't guess just by looking at it. You have to wait and see what the coefficient is. So this one's either going to be opening to the right or opening to the left. Okay, so here are your answers on those ones. So this would have been a circle, number 3. You could write it as x minus 3 squared plus y plus 4 squared equals 16. Number 1 would have been a vertical ellipse. Oh, number 2 is a mean one. Look at that. This is very small. You're going up and down by the square root of a quarter. If you were graphing this one, you've got some, you're going to go -2 up 5, so I've drawn that wrong. The center is going to be at -2, positive 5. You're going to go left and right the square root of 1, and up and down the square root of 1/4 equals 1/2. So it's a tiny little horizontal ellipse, that one. That was weird. And on number 5, this is a positive y squared. It would have ended up opening over here, and your 4a equals 3, 4c, you call it 4c, not 4a. So C, your distance between your focus and your vertex and your directrix is going to be 3/4. That'll be a funny one, that one. That's another one that's awkward to graph. A reminder about your homework yesterday. You're given a worksheet. The front for the homework yesterday, I hope you remember to change question number 4. The back of that worksheet is the homework for today. And there's this suggestion I've got written here about finding the eccentricity of each ellipse. You could come back and do that after tomorrow's lesson. We're going to learn about eccentricity tomorrow, and we actually have a whole worksheet on it, so I don't think you need to do that. In the past, we haven't had enough practice on eccentricity, but we put in a whole day for it today. Okay, so that's the end of today's lesson.